Hello again. Thank you. My name's Chase Douglas. I'm the CTO and co-founder of Stackery, which is serverless acceleration software. We help teams become high-performing as they build their serverless applications. We've been doing this for a number of years now, and we've learned things that teams have had to figure out, how to overcome specific challenges, things that are not obvious, and I'm guessing that aside from some of the best practitioners in this room, many people haven't even considered yet as they're starting their serverless development. So today, I want to kind of pull the curtain back on some of these more advanced techniques, and we're going to go pretty fast through them. The thing to remember is that they are techniques. Don't bother worrying about taking notes because I will share slides afterwards on Twitter, so you can follow me here at the last slide as well. You'll see it. But with that, let's get underway. I have gravitated, and I'm sorry if you heard this yesterday. I usually don't give two talks at the same conference, but I've gravitated towards solving very tricky, difficult technical challenges and helping other people do that. I've done many things, including bringing multi-touch support to the Linux operating system. As a technical architect of New Relic browser application monitoring. Now I'm the CTO and co-founder of Stackery. I've seen lots of things. I've seen businesses have stupendous success and what that looks like. I've also seen businesses that have been impeded because infrastructure couldn't scale, processes couldn't scale, engineering orgs that didn't know what was deployed where, what applications were deployed in production and staging, and how. And I've spent the past few years figuring out how do we make sure that everyone doesn't fall into these same pitfalls with the newer technology that's serverless. I'm guessing most of you here have already built a serverless app, even if it's a toy thing that you were just playing around with. Some of you have pushed it out to production. And I'm willing to bet that everyone who has had significant learnings from thousands of paper cuts along the way. AWS, they love to have this promise of how Lambda works. It sounds amazing. In reality, it's a little different. Some suggested edits. AWS Lambda invokes your code sometimes when needed and can scale to support certain rates of incoming requests, but requires you to properly configure everything. There are limits to the number of requests your architecture can handle. So we're poking fun a little bit at some of the challenges of serverless, but in truth, you can do the same thing with any technology. And as tons of people love to pit serverless against containers, here's the promise of Docker from their webpage. And the reality, it's not hard to go online and find people who have become exceedingly frustrated with its own challenges. The truth is that what you have to be able to do, this is why we have humans as software engineers, is you have to figure out where you need to apply human logic to overcome these challenges. Because we know that many companies have been extremely successful with serverless. They're not all tech-forward companies either. Sure, you've got iRobot, but you've got the Coca-Cola company, you've got Thomson Reuters, you've got Nordstrom. These are companies that have gravitated towards serverless because it's enabled them with the developers that they have available to them to rapidly iterate and deploy extremely high-value software. So today, I want to talk about 3 software lifecycle gaps that we've identified in practically all companies that are building and embarking on this journey of serverless application development. We're going to talk about how to manage advanced concepts of infrastructure as code, how to test, and how to monitor and instrument effectively. So let's first talk about managing infrastructure as code. And I love on Twitter recently, so many people have been talking about how serverless is like Lego blocks that you put together, you piece to create a larger thing. You're able to go into this management console and point and click and set up things that took weeks in the past, or you'd have to go and ask other people to go and provision hardware to do. and you show it off to your team. They're like super impressed. They love seeing this and how quickly you did it. And they start to ask you, how do I do this too? And you realize that there's no more clicky click for you. You have to go figure out, how do I do this infrastructure as code stuff? So today we're going to solve some of the hardest infrastructure as code challenges. We're going to look at permission scoping as sort of a public safety announcement and as a mechanism to level set and make sure everyone here understands some basic concepts of infrastructure as code. We're going to talk about namespacing resources, which enables collaboration among a team sharing AWS accounts and other cloud service provider accounts. Parameterization, custom resources, and how we can intermix existing resources into our applications. We're also going to use AWS SAM/CloudFormation as a stand-in for all kinds of forms of infrastructure as code, but it helps to have one that we choose as we go through examples. But the same principles apply elsewhere. Couple of quick definitions. I tend to refer to stacks. We're Stackery, we help you create stacks. They're instances of applications that you deploy from an infrastructure as code template. And a resource is a specific component of an application, such as a function or a NoSQL table or a pub subtopic that's specified in an infrastructure as code template. So let's talk about how we start to build infrastructure as code templates, looking at an example using scoped permissions. This is a template, and I'm breaking the first rule out of the gate. This actually is not AWS SAM. This is a serverless framework template, but it's because it's this widely known template. It is for a function that's going to be invoked when a bucket has an object uploaded to it. And that function needs to be able to access the content that was uploaded. So it needs permission to access that bucket. So this widely used example specifies permissions that allow access to do anything with any bucket in your AWS account. And that includes deleting objects or even creating and deleting entire buckets. So we need to find a way instead to scope access to specific actions, such as only being able to get an object from a bucket, and to scope access to only specific resources, only to this one bucket that I need to use for this application. So here's a simple template. I'm switching slightly because it's a little bit easier to talk about topics than buckets for this example. But we've got an SNS topic we're creating. That's what's circled here at the bottom of this template. And then we're going to use that, we're going to access it by publishing messages from a function defined above. But the way that we do that in AWS SAM is we have these policy templates. So this policy template allows us to publish messages to a specific topic that we name here. We get this name as an attribute of the resource that we defined below in the template. So what we're seeing here is both a suggested way of creating a scope down permissions policy, but also as a purpose of this talk, you're starting to see how you can reference values of one resource from another resource. The topic is going to be created first because the function now has a dependency on that topic to get its topic name so that it can have the right permissions to it. So now we've kind of level set a little bit. Let's go into a slightly more advanced topic, namespacing resources. We've got our same template that we had a minute ago, but we kind of glossed over something. We're using a topic name, but what actually is the name of that topic? And the answer is that it's kind of a bunch of gibberish, especially this random part added on the end. Now, most people, when we talk with them, they've got three goals for naming resources. They want to understand what application it's for. They want to understand what the environment is. Is it production, staging, test? And they want to understand what the resource is, because you may have 5 functions that make up an application. So which function is this? We can solve this in a pretty simple way with a couple rules. First, we can name our stack based on the application and the environment name. We mix with that when we specify our resources, we hard code the name of the resource so that it's not generated for us with some random stuff, but we interpolate using a string substitution intrinsic function the stack name in. So that makes it possible for us to end up with resource names that look like application name, staging name, or environment name, and resource name. We've achieved all three of our goals. Parameterization. We're starting to get slightly more complex here. One great use of this is not putting your database password in your template. Because you're gonna try that, but that's gonna get committed to code that's in a Git repository. It's too easy to make that public on GitHub. On top of that, you would have to use the same password for all of your environments, production, staging, test. Clearly, there has to be a better way. I must admit, I'm going to show you a way that is not quite optimal, but it was the best as of yesterday about, 2 p.m. And then AWS dropped a ton of new CloudFormation capabilities, integrations into Secrets Manager. So this part of the talk do not replicate in code, but replicate in theory. You should be using Secrets Manager to store your database passwords, and it's a different way that you interpolate in. But let's look at this in theory. So we've got a parameter that we're passing in, and it's our database password. It's a string. And we reference that. Pretty simple. Now we can deploy it out by running this command line tool and specifying the argument. We can script it using environment variables. But we realize one of the problems with doing it this way. I can easily use the API or go into the management console, and it's going to tell me what that parameter was. It's not very secure. We can go back. We can find another option that tells us, don't echo this back to me. All right, we've solved that problem. But now we've got another problem underlying this, which is where do I store these passwords? Like I can create a script that runs that command and supplies it, but that's kind of janky one way or another. And it turns out that all infrastructure as code solutions practically have a parameter store mechanism. AWS has parameter store, and now they have Secrets Manager finally integrated with CloudFormation. So you can upload your password to a certain location. Here we're uploading it to backend prod DB password. So now we go back to our CloudFormation template, and we tell it using the specific CloudFormation syntax, which is a little wonky, where it can fetch that value from the parameter store. So this shows how you can start to build on some of these foundational concepts of infrastructure as code that a lot of people don't dive into at the outset of early Hello World applications. Let's dig a little bit deeper into an extremely powerful mechanism that hardly anyone talks about, and that's custom resources. Let's say that I've got a use case. I'm going to provision an API, and it's going to have a custom domain, and I need to then update a DNS record to have the CNAME mapping from my custom domain to that API gateway API. Now, if you're running on Route 53 from AWS, that's very simple. There's a resource for that, no problem. But let's say that your DNS is running on GoDaddy, and so you need to interact with their API. So you could deploy this out first and then have other scripts that then go query after the fact and update GoDaddy or do it manually. But what if we could just do that as part of our deployment itself using CloudFormation? That's where custom resources come in. So here we've got a template. We've got two resources that are going to kind of work together in parallel. At the top, we've got our custom domain that we're creating in API Gateway. At the bottom is a function, a Lambda function, that we have created with code to be able to access the GoDaddy API to update DNS records. We tie it together with this resource in the middle that says when all the properties have been realized, so effectively when the custom domain and the function have both been deployed, pass properties about them, the custom domain, the CNAME itself, and the domain as well, the pretty custom domain, pass that to the function to invoke it. And that function can now go in and create that CNAME record for you automatically. Let's look at another example. Let's say that you're using a SQL database as part of your application, and you need to make sure that its schema is always up to date. A lot of people find ways that they script this to update the schema before or after they update their infrastructure as code. But what if every time we deployed, we automatically updated our schema? So we're going to have here another template with a DB Migrator custom resource that's going to invoke our, the DB Migrator is the function that has the capability that we've coded to migrate our database. We've got this trigger that's our custom resource that's going to run anytime its properties change. Well, we can make sure that happens by passing in a parameter that changes on every deployment, like a timestamp. So now we go out and we script so that every time we update our stack, we pass in a timestamp as a parameter. That's going to automatically trigger our database migrator function to run. So we're starting to build up some advanced building blocks. We need to start to put some of them together for a greater use, and that is being able to intermix existing resources into our applications. Let's say we've got the world's simplest serverless app. It's a DynamoDB table that when records are modified, it triggers a function to run. And you say, from some of the stuff I've learned earlier in this talk, I know how to easily deploy different environments with different resource names so we can collaborate as teams and all that kind of stuff for dev and test and prod. You know, it's a pretty simple template. I've got a table that I've defined down at the bottom. And in SAM format, when I define my functions, I'm creating an event property that hooks the stream that is intrinsically part of the DynamoDB table up to invoke our function. But this is something that practically every one of our customers has asked for at some point in their journey of adopting serverless applications. What if I need to use a resource that already exists in production? I already have this DynamoDB table that has existed for 5 years, but I need to be able to access and use it now with my new application that I'm creating today. But on top of that, actually, we'll start there. Say we've got this parameter that we're going to add, because we learned about parameters earlier. And this parameter is the identifier of the DynamoDB table stream. So we're going to pass that in, and now we can reference it. So we're starting to get somewhere. But now I can't easily provision tables for dev and test. They're no longer part of that same template. I have to go and create those tables first and pass in the identifiers somehow. So what can we do about that? We're going to get a little bit more complex. This is the same template, just broken into 2 pieces. We're going to have a parameter that we pass in that, again, is still the identifier for the stream of the DynamoDB table, but it's got a default value. This is just like a sentinel value. It's something we can look for, that if we don't provide an actual stream ARN, then it's just going to default to the value false. And we can create a condition that's going to look for that false value. And it's going to tell us, do we need to create a new table because nothing was passed in as a parameter, or do we need to use an existing table because something was passed in? When we go into our resources, now we only want to create that table if nothing was passed in as an identifier for that DynamoDB table stream ARN. And lastly, we need to have a conditional that flips between, are we going to use an existing table that was passed in or are we going to use a stream from the table we've created here? But what if I need multiple attributes of this table? I could go and parameterize this and specify all of them, but it would get quite tedious and error-prone. So what about custom resources that we talked about? We're going to get only slightly more complicated here. Same parameters, we're adding one new conditional. And this is just because in CloudFormation, you can create an inverse conditional, but you can't easily use the inverse of a conditional elsewhere in the resources. So it's just, are we going to create a table or are we going to use an existing one? But here's the interesting part. We're going to create a new resource when we are using an existing table. This resource is going to be a proxy for that existing table, and it's going to act and behave the same way as far as CloudFormation is concerned. When the condition says to use an existing table, we're going to create it, and it's going to be passed in the fact that it's a DynamoDB table and what its ARN is. Notice that the parameter did change slightly. We're no longer passing in the stream ARN of the table. We're passing in just the top-level identifier of the table. Because what this custom resource is going to do is it's going to take that top-level identifier, and it's going to go and figure out what is the stream ARN, what is the name of this, what is the other properties of it. So in our template, we're now either creating a resource that is an actual DynamoDB table with actual attributes, or we're creating a custom resource that returns the same attributes. It's a proxy, it's a stand-in. And then our events become a simple switch between using either that existing table through a proxy resource or using the new table that we've created. So now we've got a mechanism for creating a new table in dev, in test, in staging, but using that production table that we've had sitting around all along. So I hope you've kind of followed along. Again, I will post the slides for this afterwards, but it gives you a sense of some of the more advanced topics that teams need solutions for as they grow with serverless applications. I want to talk a little bit about testing, and I apologize a bit if you saw my colleague's talk yesterday about testing. He went into much more depth about this topic. I'm just going to kind of hit at it a little bit. The main takeaway is that serverless does not change testing at a fundamental level, but it does change how you test. Unit tests do not change at all. We have a very normal, very useful paradigm where your unit tests just test certain algorithmic parts of your application, and it has nothing to do with the fact that it's running in a Lambda versus a container versus on bare metal. You're just testing little units of functionality. But there's a question around how to do integration tests and how to do system tests. Because we've got a system now, a serverless system, that has an amalgam of resources that we put together to facilitate our business logic, when in the past we might have a more monolithic application that was much easier to kind of mock a few things and test the whole thing at once. There's generally two schools of thought here. You could either always test in the cloud, or you can use fake services for local testing. There's pros and cons of each. The pros of testing in the cloud is that you have a faithful representation. You know that permissions are going to be honored, rate limits are going to be honored, and that it's possible to do this today in the sense of, if it works in test environments, it's going to work in production environments. But the downside is it tends to be a little bit slower because you need to find ways of reprovisioning your resources every time you make a change. It also requires cloud access, so If you're on your transatlantic flight from, say, Portland, Oregon, it becomes a little bit harder to get things done. But I would hazard to guess that most people here do not spend more than 1% of their time away from internet at this point. So not as big of a deal as it used to be. Integration tests with local fakes. So this is where you run a version that a piece of server software locally, oftentimes in a Docker container, that is a stand-in and behaves very similarly to other services you're using. So there's fakes for API gateway, fakes for DynamoDB and S3, so that it looks the same to your software, even though it's running on your laptop. And the benefit of it is that it tends to be faster. You don't have to redeploy everything to the cloud to test. And it doesn't require cloud access at all. But in practice, there's challenges in that you'll find skew in behavior versus the cloud. It's very challenging to test permissions, which is one of the biggest problems that people hit when they're developing serverless applications. And it's not particularly well supported today, in the sense that depending on your tool set, you may be able to spin up an API gateway, or maybe a DynamoDB table, but maybe not S3, maybe not secrets manager, or parameter store, or all these other things. But upstream projects are trying to make this possible, and we see vendors, primary cloud service providers like AWS, doing their best to make this possible. They've got AWS SAM Local that can help you spin up your API gateway so you can test locally. So there's some advice that we give to people. It's for today only because things change so rapidly, as we know. If your application is only endpoints of an API and functions, then it's fine to do local tests. But in practice, hardly any serverless applications are like this. So otherwise, deploy into the cloud and test. The key here is that with the right approach, serverless is just as testable as any other form of architecture. You just have to have the right mindset and the right tooling around it. So lastly, I want to talk about monitoring and instrumentation. And I find this a really interesting topic, partly because we're going to look at a really cool advanced topic around metaprogramming, but partly as well because what it enables people to do that they didn't have without good instrumentation is quite amazing. I was speaking with one of our engineers a month ago, and he was remarking how surprised he was that when we have issues, I mean, I admit we have errors occasionally in production. When we have issues, we tend to be able to diagnose and fix whatever the underlying error is the first time we see it. Now, some of you, that may be normal to you, but for a lot of people, without the right monitoring and instrumentation, it becomes very challenging. It becomes a game of, we see this behavior, we know there's an issue, but now we need to add some debugging lines to figure out where this is happening. And you get closer and you redeploy, and then you realize you're still not quite sure, so you add more debugging logs. I think Charity Majors earlier this morning talked about this. There's a challenge of making sure up front everything that you do has the right monitoring and instrumentation so you can quickly turn around fixes or learn new insights about how your users are using your product. So how do we achieve this today? Typically, an organization picks a set of monitoring tools. They may say, I'm going to use Rollbar for error aggregation, Epsagon for tracing, Splunk for logs, and then they'll ask everyone to always instrument using those tools in the same way. And then they pray, and then they resort to draconian measures, and that just tends to piss everyone off. there's got to be a better way to do this. So how should we do this? Well, we start out the same way. We pick a set of monitoring tools. But then we need to find a way to define instrumentation rules centrally so that we say, I want every function to automatically send errors to rollbar, to automatically send traces to Epsagon, to automatically send logs to Splunk. We do that by using a framework, a set of tools, a mechanism that auto-instruments every function to do this. And then, instead of draconian measures, we can go eat some cake. So how can a framework auto-instrument all these functions? Let's look at a simple example. We've got a function here, trivial. All it does is add two properties of an event passed in. And we define it at index.js as our handler function. We don't want to modify any of this code. We want our developers to not have to think about monitoring and instrumentation as they are thinking about their business logic. So we have this process now where instead we slip in at deployment time a second file called instrumented.js. And what that does is it loads the handler function from our index.js. That's the require statement at the top. And then it creates its own handler that it exports that will wrap the original handler in a try-catch. And if that original handler has an error that it triggers, it throws, we capture that, and now we send it off to rollbar. All we have to do at this point is update the handler for our function from index.handler to instrumented.handler. So if you have a development process that can slip in an extra file at deployment time and update the handler in your template, then you have achieved a mechanism for auto-instrumenting all of your functional code. So today, we talked about all these techniques for overcoming these software development lifecycle gaps of serverless, how to manage infrastructure as code, and mixed in with that was collaboration mechanisms, especially around namespacing, resources, how to test, how to monitor and instrument. I apologize, instead of Swiss cheese, I thought in London I might put this slide in. How will you manage the gaps around your software development life cycle? You can choose to build all the things that we've talked about here and more on your own, but it tends to be a lot. We've spent the last 2 years at Stackery, 2+ years, observing and building our own high-performing serverless team. We've learned how to help people manage their configuration, how they can collaborate as they develop, test, and monitor, how to provide consistency so that they're sure that every function goes out the same way with the same instrumentation. So our suggestion, I'm biased here, I understand, but is to use software that does this for you. And that's what Stackery is. It's software that helps you design and architect your serverless applications. It's not just a rendering, it's a full two-way binding between your SAM or your serverless framework templates that you can import. Then helping you deploy by preparing all of your functions, being able to run npm install for your Node packages, Gradle build for your Java, .NET build for your .NET functions, whatever your language is. Deploying that out, giving you a health dashboard with all the top-level metrics and links to dive into the management console for where logs and traces are, all with the permissions model that ensures that we don't have access to change your infrastructure. We can only propose changes to it, allowing you to stay in the driver's seat for managing it. So if you want to talk about anything here that we talked about in this presentation or any way that we may be able to help you, please come seek me out. Again, my name's Chase Douglas. I'm the CTO at Stackery. You can make note of my Twitter handle here. I will post the slides from this as soon as I get a chance this afternoon. And thank you.